on page 20, there's a section in the standard system that deals specifically with piling. And it says that we need to look at the site conditions. In the site conditions, it says that the nature of the site with regards to the contours, the water tables, high and low water levels, strata through which the piles would have to pass, etc., shall be described. So when we do the excavation for the piles, it is important for us to indicate what those conditions, what the site conditions are. The same as for how we would for our normal excavations. You would do the exact same for that as we would for our normal excavations. The nature of the work. Any limitations on the methods to be used. Special conditions, such as the piles sunk from a basement level or from which level the piles would have to be sunk. We would have to describe that as such. Sometimes we need to do trail piles. Trial piles, whereby we need to see whether the depth that has been designed by the engineer is sufficient. We need to do a trial pit where the trial piles would be inserted. Sometimes we need to do raking piles. In the establishment, we would have to establish the site, establishment of plant. For each pile, we will have to ensure that we measure that. So the establishment of the plant, etc., on the site will be measured as per item. The reason for that is because we have different numbers of piles dependent on the size of the structure, dependent on the size of the pile cap, dependent on the weight of the structure, dependent on the aggressiveness of the soil conditions in which we need to excavate for these piles. We will have to do a plant establishment for each and every pile. A subsequent establishment for the plant, etc., for testing, because we also will have to test that. And all of those, remember that as QSs, we will only measure that. The piling contractor, which generally is a specialized trade, and that would have to come might fall under the nominated subcontractor section. That would be done by companies such as Frankie Pile, etc. That would be, and they would understand and would know how to price and to do those for us. The setting up of a plant at each pile position, other than sheet piling, shall be measured and shall be given in number. So it's important that we do that for each pile. Remember, if we have 10 piles, you'll have 10 setting up of the plant at each pile position. The reinforcement shall be given in accordance with the principles laid down in concrete formwork and reinforcement. For those of you who were in my first year class would understand that when we deal with reinforcement, and at the time when we measured the spring, you measure the spring. Remember the spring. We would now use the same formula for determining the length of this spiral reinforcement in here. We'd use that same formula that we had back then. Now you'll understand why we were doing these. Exposing the piles for inspection. It's important that they get inspected to ensure that everything was done correctly in the pile. We normally would clear the pile, the top of the pile, in order to see what the density of the concrete then is, whether there would be honeycomb in that or not. Because honeycomb, what does honeycomb refer to? Honeycomb refers to weakness. So it's water that has disappeared from there, and it does not form the bond. So it's important that we have that in there as well. Cutting off of the piles to the top. Why do we cut them off? So that there's a bond between the pile and the pile cap, the reinforcement of the pile and the pile cap, so that it forms one. The testing of our piles. And that is what we will be measuring over here. So next, guys, I will be going to what I've uploaded on MSD, RC008. RC008. And I just want to state that I'm in the process of getting something where I can actually physically write and describe and not have to use the mouse. I'm hoping for that it will work, because I do understand it is not the best for you guys to witness whilst we lecturing modules such as this. Are there any questions before I continue, before I upload before I upload the drawing first and foremost, and then the workings out of RC008. No questions? Okay, if there are no questions, then if you would allow me to upload drawing 008. Okay, can you see my screen?
Yes, sir.
Okay. Okay, so you can see my screen, right? Okay, if we have a look at the screen, guys, and I'll just have to reduce it somewhat. Okay, so we can see everything on there. If we have a look at this drawing RC008, what we need to look at who came in here and then left. Okay, if we have a look at this drawing, we realize that in this drawing, this is a straightforward drawing with with only one pile in the bottom, with the pile caps on top, and you'll notice that the information is given to us. It tells us that the pile cap is size 1200 by 1200. It has a thickness of 600. We then take a look at this section over here that I've highlighted there. In that section over there, it will tell us how many of these piles and pile caps are required. This is our legend. It gives us the diameter of my pile. It gives me the diameter of the reamed section at the bottom. Why do you think we would have this reamed section at the bottom there? Straightforward. In the event of severe movement, it's like if you have your hand, if you stick your hand and arm into a hole and you then make a fist, it's difficult, almost near impossible for you to get your hand out of that hole with your hand being in a fist. And that's the same reason as to why we have this enhanced section at the top, at the bottom of the pile here, to prevent that pile from being moved out with aggressive movement that might take place underground. And that we see there that it is 900 millimeters wide, the enhanced section there. L is the length of my pile from the top to the bottom of my pile. That's the length that is given to us over there. We then see that the steel is 12 millimeter diameter mild steel. The steel that we have that will be used in there. The mild steel number would be 8, and that would be the vertical length of the steel. If we have a look at, we do not have a section from the top, but it would be these strands that you see. It would be these strands that you see down there. That would be the vertical. That would then reflect over there. The mild steel length of those steel, mild steel 8 millimeter diameter length. That would be that would be 7 meter 800, and the spiral would then be 10 millimeter diameter. The spiral would be 10 millimeter diameter. So that the verticals would be 12 millimeter diameter, and the spiral would then be 10 millimeter diameter. And the spiral P, if those of us who can still remember what the P stands for, that is 180 millimeters. If you cannot remember, you will have to you would have to look into that so that you can go back to your first year notes so that you can find out what that would then mean down there.
Righto.
So it tells us that we have 14 of these piles. It also tells us that the piles are 7 meter 800 long, and that the pile cap at the top is 1200 by 1200 by 600 millimeters deep. So we need to understand that when we now start measuring this, which I will upload, which I will also upload now.
Excuse me, sir.
Yes, Mr. Madolo.
Is the pile cap square or rectangular or circular?
Mr. Madolo, you can see there, it gives us 1200 by 1200.
Okay.
So what does that mean? It means that it is square. Yeah, but this is because we would only have, if I can draw this from the top, you'd have the pile cap there, you'd have the pile sitting at the bottom of that. This is not, I should have drawn that dotted line, but that is what, 1200 by 1200 with the pile sitting underneath there.
Sir, do you ever have the pile cap circular?
Not necessarily, Mr. Madolo. The pile caps would come square, rectangular, pentagon shape, octagon shape, hectagon shape, different shape, but I've not come across circular pile caps.
Thank you, sir.
Okay. Right. When I now upload, I'm going to take this down and then upload the workings for does my screen show?
No.
Oh, I've not pushed the upload. Can you see my screen?
Not yet.
Can you see my screen with the Excel spreadsheet indicated?
Click on it, sir.
No, sir.
Not. We're back to that again. Okay, so I will try something different. Okay, let's try this one. Nah. Take it you can see my screen now?
Yebo. Yes, sir.
Yes, we can.
Okay, right. Now, you've now seen the drawing. I've gone through that and I've shown you. I'll just jump. It should show both. You can see my drawing now. Change over to the drawing.
Yebo.
Okay, if you can see the drawing, it says to us that we have 14 piles. That's a number that we need to measure. So meaning 14, everything that we'd measure in this drawing would therefore
14.
be 14. So when I go to my, you then start out and say that the following in 14 augured cast in situ reinforced concrete piles. We indicate that how many there are. That all is in line with the standard system. That tells that we need to say how many we have that we need to cast in there. So it says that we need 14 and allow for the establishment of plant, etc., on site for the piling operations, and allow for the subsequent establishment of plant, etc., on site for the testing of the piles. Now, what does it tell me? If I go back to my drawing tells me allow for the testing of any 3 piles. I don't know, it's not slightly different. I cannot use that and. Can we please just ensure that we are all muted? Okay, so when we have to test all the piles, we can then. So what I've picked up here now is a flaw in the sense that there says allow for establishment of plant for the testing. But the testing in this instance, the drawing tells me how many should we test?
3.
Only 3. The drawing tells me so this section here would now not form part of that, and we would have a separate description here saying that allow for the establishment of plant on site for the testing of the piles, and we will then have, but that then says that we need to only test 3 of them. Okay, so for the establishment of the site, for the plant establishment, that's for the 14, and then therefore, but this would not form part of that because it will form part of the separate, whereby I will say that we only test 3 of them. When I look at my standard system, tells me that on page 20, clause 4 says the setting up the plant at each pile other than the sheet number would then be number, but clause 3 says that the subsequent establishment of plant, etc., for testing is measured in item, and I will therefore have to indicate that I only need to do the testing of 3 of those piles in this instance. Allow for setting up of plant at each pile position. Now, setting up clause 4 on page 20 in the standard system says, and guys, the thing with piles is it's so easy because everything you follow what the standard system says, and you just need to then, therefore, at this stage, substitute the quantities or the lengths that we need to determine in this regard. So the setting up, it says on clause 4 on page 20, it said the setting up plant at each pile other than sheet pile will be measured in number. So now it's easy. We say allow for the setting up of plant at each pile position. It's measured in number, and we have 14 of those as per the legend that we had received. Now, I'm not sure whether we know what auger is. Excuse me. Auger is when we have a drill bit, the shape of the drill bit is in the shape of an auger, and so that when we drill, that anything that is drilled out is then will then find its way, auger its way up to the top, or if we're drilling into timber horizontally, vertically, or at an angle, whatever is drilled into the waste would therefore, as the auger goes through, it would then be drawn out to the top. So auger in pickable material. And if you have a look at that schematic video that I showed earlier, it shows that as we drill, the rubbish comes out. As the deeper we go, the shape of the drill bit is in such that it draws the waste material out of there. So we now need to auger in pickable material for 600 millimeter diameter piles not exceeding 10 meters deep. So when we now do this, and when we look at the piles, I want to take us a little further, and I want to go and have a look at what the standard system says about this particular excavation in the form of a pile. Now, when we deal with this, it tells us we would be working in sections of not exceeding 10 meter, and we then exceed them like 10 meter, not exceeding then in intervals of 10 meter for the excavation for piles. So when we go into this, and we then excavate and say that this does not exceed 10 meters deep, we have our depth. Where do we find the depth?
7.
We find our depth on my drawing, the drawing that indicated to me that the depth of my pile from the top, from my reduced ground level, all the way to the bottom gives me a length, which is L, and that is 7 meter 800. So 7 meter 800 to do that. And we measure these by virtue of us indicating that the piles are giving the diameter of the piles and also what the category is. We would therefore drill them, as you say on page 22, it says that auger piles drilling would then be measured. Clause 12 says to us that drilling separate into groups not exceeding 10 meters deep and thereafter in successive depths of 5 meters. So it will be not exceeding 10, exceeding 10, not exceeding 15, exceeding 15, not exceeding 20, and so we'd go forth for the augered piles. So in drilling, in our description, we then therefore say that auger in pickable material for 600 millimeter diameter pile not exceeding 10 meters deep, and we have the length, which is 7.8, and we have 14 of those. Okay? Now at the bottom, as I indicated earlier, we would now have to expand the foot of this pile. And we say extra over augering for 600 millimeter diameter pile for under reaming for an enlarged foot 900 millimeter in diameter. And that we can see over there. It goes wider, it's 900, D there tells me it's 900, and the small diameter is given as 600. So we now need to measure, remember that we've measured this, down there, we've excavated down there. So while we now need to allow for that section there to be broadened, and we measure that as extra over augering for 600 millimeter diameter pile for the under reaming for the enlarged foot 900 millimeter diameter, and that is measured in number as per clause 12 subsection 21 on page 22. Under reaming for an enlarged foot shall be given as extra over drilling and measured in number. That's according to the standard system.
Makes it too easy.
We then need to measure our concrete. Whoa, but how do you measure concrete in number? 30 millimeter diameter reinforced concrete in 600 millimeter diameter piles. And now it says to us that concrete would be measured through the enlarged feet. That's on subclause 24. On page 22, it says that concrete will be measured in meter and measured through the enlarged feet. So when we measure the concrete that, we will not now be specific with being pedantic with how we measure. We measure through that and we measure in meters because we've already indicated that it has an enlarged feet.
Yeah. Yep.
But we do indicate that separately by saying that the additional concrete 30 MPa in enlarged feet, 900 millimeter diameter for 600 millimeter diameter pile, and we measure those in number. Subclause 25 in the standard system tells us that additional concrete in the enlarged feet is measured in number. What have I done with my standard system, electronic standard system? Let's see that here. Okay, but that is on. Should maybe just upload that so that everyone can follow what is where I am. Is my standard system shown here?
Yes, sir.
Yes, sir.
Okay. So this is on page 22. This is what I've now been measuring. Measuring the auger of the piles in the various lengths, the underreaming for the feet of the piles, looking at the concrete that goes in there, and also the additional concrete that it says is measured in number. And when I go through and I have a look at how I've measured that, the additional concrete, it's measured in number, I've indicated, and it's important that we indicate the size of the feet, the size of the pile, and just the number, how many are needed in there. The next item refers to the stripping back of the head of the pile cap, of the pile. When I look at my drawing, stripping back, you notice that the pile cap sits, and you see that the 600 is indicated over there, but the pile cap, and if you have a look at the different levels, 99,600 versus 99,400, it tells me that this pile cap is placed 400 millimeters below the reduced ground level, as the pile cap depth is given to us as 600. So I now need to measure the stripping back of this pile. That I need to measure. So that height there would be 400. And I need to indicate that. And I indicate that strip back the head of the 600 millimeter diameter concrete pile for a length of 400 to expose the reinforcement. Now, why do you think we need to expose the reinforcement? Why do you think we need to expose the reinforcement? Anyone want to indicate why they think that the reinforcement needs to be exposed?
I think for you to be able to tie in, if you need to extend your reinforcement maybe for the pile cap, if you need to tie in into the pile reinforcement.
Absolutely, Madolo. That is absolutely correct. Because we know and we've learned through our previous 3 years of study that no bond is formed unless we have a bond with the steel work that's in there and the steel structure that goes over that. And now this steel structure that goes over the structure that goes over this pile cap would be a reinforced concrete pile cap that would go in there. That would also have its own cage. We also note that on the top of this pile, that would be smooth. Why is that? For reasons that with all the movement that takes place in the ground here, you do not want the structure on top of this to be bonded to that, and you want the movement there so that the structure on top can actually move or remain stable when everything below moves. So you'll have a construction joint over there, what you call a shear joint. You guys would know that deal with these. So we would now therefore strip back the top of the head of the pile for a length of 400 to expose the reinforced concrete. Now we measure for the testing of the piles. Testing of the piles or the 600 millimeter diameter piles, and we see that we were told that we only need to test 3 of those piles. Of course, the engineer will indicate. The contractor would not be asked to do that on his or her own, but the engineer will indicate which ones they want tested as in order for it to indicate exactly how that should be brought about. Now, something that I now missed out on. Okay. When I look at my next item, my next item that I measured now would be extra over-augering and under-reaming for piles and carting away the surplus excavated material. We now need to determine what the volume of that material is that we need to cart away. We need to determine what the volume is, how much of that do we really have to now indicate in here. This is where I wish I had my pen, my device already where I could show this. Now we'll have to try and draw this with a mouse. Okay, if we go and we now look at my pile, I now need to, if I can make it clear, I now need to look at what that volume of that material is that I need to take out here. If I go in and I have a look at my shape, what shape do I see? The pile is cylindrical, right? And what shape do I have at the bottom here?
Frustum.
What shape do I have at the bottom?
Frustum.
Because?
I was saying a circular frustum, sir.
A partial circular frustum. Yeah? It's a partial circular frustum. Now, if we look at the dimensions, now I'm gonna throw the cat among the pigeons here. If you have a look at this, you see here that first and foremost we measured the cylinder. We've used the radius of 300 by 300 by the length of the pile, 7 meter 800, and it's times pi times 14, which makes sense because that is the volume of a cylinder. Okay? Then we look at the next one. The next one has a dimension of 2.2. Now, where on earth do we get 2.2 from? What is 2.2? I now need to determine what that 2.2 is. I need to measure the circumference of this foot. I need to measure the circumference of this foot. But from there to there, what do we have? 900.
Mm-hmm.
As the diameter there is at 900.
Mm-hmm.
Right? So if we have a look at that, it is at 900. But in order for me to determine that is there, what do I have? If I could draw this, so try and draw a circle, which is not the best. And I have my pile on the inside. Remember, I've already measured that. I now need to measure everything around there. How do I measure that? The one thing that I can do, because I've already measured there, I now need to measure everything on the outside. And you've learned in third year structures that in order to find the center line of this, we need to work a third from the base. Is that correct? third from the base. So if this is 600, then it tells me that that is 150 and that is 150. Do you agree with me? Because overall my large diameter is 900. Okay? So in order for me to determine what that length is, I will have to say 150. A third of 150 gives me 50. Do you agree with me? That's quiet now.
50, yeah.
Third of 150 is 50. So I will then have to indicate that from the center here to a third of 150, it will therefore be my 300 plus 50 and that gives me 350. That gives me 350. So the 350 is from where you can see my cursor now to the center point of my extra section, of my rim section. And that will mean that in order for me to determine the circumference, it will be the circumference from there.
All right. The circumference around there.
To there. I know it might not make lots of sense, but it'll be the circumference that we will have not of the outside, but the circumference of 50 millimeter into my rim section. That's the circumference that I need to determine. So, if I have the 300 plus the 50 millimeter of what I had now learned working from the base of my cross-sectional properties in structure, then this instance will be 150, a third of 150 plus the 300. I can then work with that and I say that it is then, the circumference is then 2 times pi times the new radius that I've now determined of 350, and that will then therefore give me, if you can calculate that, it should give you 2.1991. So that in essence gives me 2.2 meters of a circumference. I need questions.
That's correct.
Do we have questions? Are we okay with what I've just said?
I think it's understandable because
Everybody good with what I've just said?
That's correct. It's correct.
Could you please repeat it? I didn't hear you clearly.
You don't hear me clearly. Okay. Right. I'm saying that. Which section must I repeat?
All of it, sir.
I heard you up until where you got the 350. After that, I didn't hear anything.
Okay, Nomta, you said you heard me after I got this 350 here. Right.
Yes.
Okay, now that 350, I'll say again, take me from the center to 50 millimeter into my section, my rim section. Now I need to determine. Yes.
Can you please just move a bit below that, where you get this 51 first, a bit lower.
Where I get the?
51.
No, that's not 51. That should be 50.
50. Yeah, can you please just elaborate there?
Okay. What I'm saying is, if we have a look at that there is the rims, is this section here that's enlarged. Okay? And that there is 150. Right? And when we deal with known structures, if we need to determine the circumference of that section, because this goes all the way around, I will have to now work to a third of the base. And a third of 150 is 50. Third of 150 is 50. So it will be the 300, which is my normal radius, plus the 50, which is a third into this reamed section. And then I now need to determine the circumference of that you can see where you can see my cursor. Now I need to determine that circumference, because that will give me the center. And when I have a triangular shape, the triangular shape tells me that I work a third for the center line of that. That's a third off my base, and that is a third off that, and that gives me the 350. And my formula would then be 2 pi radius, and that radius is therefore the 350 millimeter that I have determined, and that then gives me 2.
Correct from structures foot.
0.199,
Centroids.
and because I work in 2 decimals only,
2.2.
that means it is 2.2.